All right, everyone, welcome. Homework number 5 tonight. Let's start with number 7-46. Each pair of congruent triangles below determine the triangles are congruent. If the triangles are congruent, um, state the congruence property. Determine a sequence of rigid transformation that maps one onto the other. All right. So for each of these, we need to first find out if they are congruent to each other. Okay. So just examining this. I'm just looking at this right here. Maximum zoom. No fun. Anyways, looks like I'm gonna look at triangle ABC. So it looks like I have angle B, angle A right there, double. And then looks like I have a side. So it looks like an angle side. Right? And then on the bottom one, triangle DAC, we have angle D, angle A, or at least a version of angle A, and then the line. So yeah, looks like they are congruent. So this one says angle ABC. So we go from blue to red to no angle. So when I'm gonna name it the same, it's gonna be blue. So it's gonna be angle A, triangle A to red D, and then C. Complete the congruence statement. Done. State the congruence property. This is through our angle side congruence, and determine sequence of rigid transformation. This one, if I just flip it over, right, if I just do a reflection across the x-axis, it should actually land one on top of the other. Okay, so this would be a reflection across the x-axis. That's it. Part B. Let's see. This one looks like all we have is an angle. So got two angles the same, and all we have is a side, or sorry, another angle, but nothing else. And we know that there's no such thing as just angle, right? So this is the otherwise part. Explain why you cannot conclude triangles congruent. All right, so we're gonna say triangle PLM is not congruent to triangle NOM. And this is because angle is not enough or not sufficient to determine congruence. And let's look at C. Let's see, triangle WXY. Looks like we have an angle. They both have ones there. Looks like we have a side. They both have two there. And looks like we have another angle. And these angles both have twos also. That means that they're congruent to each other. So I'm going to say yes, they're congruent. Okay, so let's see. It looks like WXY XY. So it looks like I go from white angle to blue to red. So it'll be white, which is going to be, well, what is that down there? It looks like a T. We'll say that's a T. WXYZ. Yeah, we'll say that's a T. So it looks like it's congruent to angle T, to triangle T, Z, Y. Okay, and this is by angle, side angle congruence. Okay, and how do you get it? Let's see. All we got to do is rotate this. So if you think about this, if we rotate this counterclockwise or clockwise 180 degrees, it should actually do it. So I'm going to go ahead and say rotation of 180 degrees counterclockwise, or you can even say clockwise if you want, because if you turn 180 degrees, it looks like that. And if you do clockwise 180 degrees, it's going to actually look like that. So either way is fine. Okay. For parts A and B, write a recursive equation using AN. Okay. So remember, recursive is you need write a couple terms. So I'm going to say A1, A sub 1 is 108. And just for kicks and giggles, I'm going to do A sub 2. To do that, you need A sub 1 or the one before A sub 2. And that's going to be, and then we're going to add on whatever that what's going on. And we're actually going, and we're going to add plus 12. It looks like the same thing, plus 12. So it's going to be A1 plus 12, right? So A2 is going to be A1 plus 12. And if we do A3, then it's going to be A2 plus 12. Right? It's just the one before. So this is going to keep going. And if we finally get to AN, then it's going to be the one before. So what's before N? Well, it's going to be AN minus 1 plus 12. Like that. Okay, so this one, we're going to write down A1 equals 2/5. A2 equals 4/5. Oops, sorry, I don't want to write that. I want to write the formula, right? So A2 is going to be A1, the one before A2, so A1 times 4. And basically, we got to figure out what's going on here. So I'm actually going to write A1, but what's going on? So it looks like from one to the next, looks like I'm just multiplying it by 2. Or you could call it 2 over 1. I'm just going to say 2. So really, A2 is going to be 2 times A1. Right? And A3 is going to be 2 times A2. Right? So again, to find A3, you got to look at the one before that, which is 3 minus 1, which is A2. Okay? Oops. So if I want to find AN, which is going to be 2 times A, and then the one before AN is going to be N minus 1. Okay? So that's A and B. C and D says, for part C and D, write an explicit equation. Okay. And for the recursive, remember, you don't need to write all of these. I actually did a bunch. But recursive, you really just need to do the first one and the next one, like that. First one and the next one. So that's actually a recursive. So this actually fits more with the recursive. A1 and then what's AN. Okay, A1 and then what's AN. Okay, I wrote a couple extras just to kind of help you see what's going on. Okay, so for these two, we need to write an explicit. So all of these start with TN, right? And to figure out, you got to figure out what's happening from one jump to the next. Okay, so when you pull up my calculator, so to figure this out, I need to start at 3702 And I'm going to go ahead and subtract the previous one, 3741. And that looks like I'm subtracting 39. And I'm going to go ahead and try it again, see if that works. So I'm going to take the third one, which is 3663, and I'm going to subtract the second one, 3702. And it looks like it matches, so it's minus 39 each time. So my pattern is I'm going to get, it's minus 39 for every end. So that's, if I'm doing repeated subtraction of 39, I'm actually going to be multiplying it by 39 for every number that goes by. And then to figure out my last part, I just got to figure out what my very first term is. What's that term right there? Right? So to go in that direction, I need to add 39. So 37, 41 plus 39. So I need 3780. So that zero term is 3780. So that's going to be plus 3780. Right? And I can check. Right? So this is my zero term. That's my first term, second term, third term. So let's just try 3. Right? So let's try T3. So the third term is going to be negative 39 times 3 plus 3,780. Okay, let me check that out on my calculator. So the third term is going to be negative 39 times 3. I'm going to write it exactly like how I have here. Plus 3780. And that gets me, yep, the third term is right here. 3663 or 3663. So this equation works. Okay, so my answer is this one right here. And these two are actually both my equations. And these two are both my equations. Okay, for the last one. Again, I'm going to use that little trick that I just showed you guys. In order to find out what's going on, I'm going to subtract the second from the first and the third from the second. So if I go 23.4, take away 117. So it looks like if I'm working this out, it looks like I'm going to be subtracting 93.6. Right? And I'm wondering if I'm doing the same thing. And it doesn't look like it. Look, 23.4 and 4.68. It doesn't look like I'm subtracting 93.6. So, but I'm going to go ahead and just show you. So I'm going to take the third one, 4.68, and subtract the second one, 23.4. And it's not the same answer. You see that? It's minus 18.72. So that means that I'm not adding or subtracting the same amount, which means that I'm probably multiplying or dividing. So I'm going to do the same thing again. And what I'm going to do is I'm going to look at the second one and compare it to the first one. And then look at the third one and compare it to the second one. Okay, and I'm going to use the calculator to do that. So I'm going to go 23.4, clear it out. And I'm going to divide it by 117. That gives me 0.2. Okay, and I'm going to take the third one, 4.68, and I'm going to divide it by the second one, 23.4. You see how it's consistent? So that means that I know that the pattern is going to be, to go from one to the next, it's going to be times 0.2. To get to the next one, it's going to be times 0.2. That's my pattern. So my equation is going to be T of n, and repeated 0.2s, repeated multiplication of 0.2 is actually going to be 0.2 to the n power. Okay, because repeated multiplication is actually an exponent. And then to do the same thing as the last one, I need to figure out what's my zero term, right? What's zero term? So if I'm going for the next term and next term, it's multiplication by 0.2. But if I want to figure out the previous term, I actually got to do a division by, it's the opposite, division by 0.2. So if I want to go this way, it has to be division by 0.2 because I'm going in that direction. So I'm going to go 117 divided by 0.2. That gets me 585. So my zero term is 585, and that's what I use to multiply. 585. Okay, and that's my T-even equation. Okay, and I can check, right? So again, this is my first term, my second term, my third term. Let's check 3 again. So T3 with my third term. So I should get 4.68. That's going to equal 585 times 0.2 to the third, because I'm using 3 for the n. So that's n and n. So whatever I use, if I use 3, then I'm going to have to use 3. So I'm going to go ahead and put all this in my calculator, and it should make this third term right here, 4.68. So I'm going to put that in my calculator right now. 585, parentheses, 0.2, close parentheses, to the power of 3. And you see how it comes up to be 468. So that means that this is my equation right here. Okay. Alrighty. I think that's the last one. Let me see. Oh, no, one more. About ready to shut you guys down. Solve the following systems of equation algebraically and then confirm your solutions graphically. We're just going to go ahead and do this algebraically. All right. So this is going to be both substitution method. When instead of y, we're going to go ahead and put in 3x minus 2 in place of the y. That's what it says. So we're going to go ahead and do this with 4x plus 2. And instead of y, we're going to put in 3x minus 2. And that's going to equal 6. Working out, 4x plus 2 times 3x is 6x. 2 times negative 2 is negative 4 equals 6. Combine these two right here because they're both on the same side. So you're going to get 10x. And then I'm going to go ahead and add 4 over, because the opposite of negative 4 is positive 4. And add 4. So I will get 10x equals 10. Divided both by 10. And I get x equals 1. So my answer is going to look like this with 1 as my x. And if x is 1, I put 1 right here. 3 times 1, I'm going to do this mentally. 3 times 1 is 3. 3 take away 2, and y equals 1 also. So my answer is 1, 1. Okay, this one right here, I'm going to go ahead and instead of x, I'm going to substitute in y minus 4 into the x. So I'm going to go ahead and copy this equation down. 2, but remember, instead of x, I'm going to copy down y minus 4. Minus y equals negative 5. Okay. Work it out. 2 times y is 2y. 2 times negative 4 is minus 8. Minus y equals negative 5. I'm going to go ahead and combine 2y and negative y, which is going to make 1y, where I'm just going to call it y. And then minus 8 equals negative 5. I'm going to go ahead and add 8. Cancel, cancel, and we get y equals negative 3. So that means my answer is going to look like this with a negative 3 on the y. And if y is negative 3, that means x is, I'm going to do this mentally, negative 3 minus 4 is negative 7. Okay, that's my two answers. All right, call it a wrap.